Welcome to this explainer. Today we're going to deconstruct literally the biggest IT disaster in history. And what we're really looking for here is a critical project management failure, one that, honestly, you might be repeating in your own organization right now. We often assume that the most sophisticated tech companies in the world are also the most rigorous when it comes to deployment governance. But as we're about to see, just one missing detail in a project management document can literally bring the entire world to a standstill. Let's dive in.
To start, we have to grasp the sheer scale of what happened on July 19, 2024. According to Parametrics Insurance, we are talking about $5.4 billion. That number represents the estimated financial losses to Fortune 500 companies alone from the CrowdStrike outage. When you look at the total economic impact, estimates actually reached an astounding $10 billion. So it is officially the most expensive IT outage in recorded history. And this wasn't just some abstract, on-paper financial loss either.
The real-world chaos this single deployment caused was completely unprecedented. Take Delta Airlines, for example. They alone reported $380 million in remediation costs and had to cancel over 7,000 flights. It was absolute bedlam. Across the globe, emergency services lost access to their dispatch systems, major banks went offline, and incredibly, modern hospitals were forced entirely back to pen and paper.
Okay, so here's our forensic roadmap for this explainer. We'll start with the $5.4 billion outage itself, then unpack the flawed governance decision behind it. We'll walk through the 5 specific points of failure, draw a massive parallel to today's AI deployments, and wrap up with a bulletproof pre-deployment checklist.
Section 1. The $5.4 billion outage.
To really understand the fundamental mechanism of this crash, we have to look past the sensational headlines. The entire catastrophe originated from a tiny 40-kilobyte configuration file pushed out by CrowdStrike. That's it. This file basically provided 20 values where its template expected 21. And when the system tried to read that missing 21st value, well, it caused an unrecoverable out-of-bounds memory read. Boom! Instant blue screen of death. But here's the thing you have to understand. This technical bug is just a quality assurance symptom. It is not the root disease. You can test your way to a lower probability of bugs, sure, but you can never test your way to absolutely zero. What you can do, however, is ensure that no single QA failure ever reaches 8.5 million systems all at the exact same time.
Which brings us to Section 2, a flawed governance decision.
This is where we need to shift our focus to the actual project management failure that allowed an everyday software bug to destroy global infrastructure. There's a stark contrast in deployment policies here, and it's based entirely on how an update was categorized by project managers. For code updates, meaning actual software versions, they went through a very rigorous staged release. We're talking internal testing, a canary deployment, and then slowly rolling out from 1% up to 100%. Super safe. But for content updates, which were classified merely as configuration data, the process completely bypassed all of that. It went directly to a simultaneous global deployment. So why the huge difference?
It all comes down to governance categorization. Early on, the logic at CrowdStrike dictated that threat detection content needed to be updated continuously, to protect customers in real time from new threats. A staged rollout taking hours was actually seen as a security risk, so content was defined as far lower risk than code. And honestly, that made perfect sense for an era of simple text files. But over the years, these content files grew incredibly complex. They became capable of crashing the core kernel driver. Yet, incredibly, the governance decision was never reassessed. This is the ultimate danger of architectural debt. You're using governance meant for a system that basically doesn't exist anymore.
Moving right along to Section 3, the 5 points of failure, sourced directly from CrowdStrike's August 2024 root cause analysis.
Stepping through that official forensic postmortem, we can see these compounding early failures. Point 1, channel file 291 was generated with that mismatched field count we talked about. Now point 2, CrowdStrike actually had an automated content validator designed to catch exactly this kind of error. But, and you can't make this up, the validator itself had a bug that was introduced months earlier, which caused it to just pass this bad file right on through. So we have 2 bugs compounding, not one, and the second bug was literally in the safety net meant for the first. Which leads us straight to point 3. Because it was classified as a content update, this approved bug-ridden file was deployed to 100% of global systems simultaneously at 049 UTC.
And this just brilliantly illustrates the blast radius of that governance decision.
According to the root cause analysis, if they had simply utilized a 1% canary rollout, approximately 85,000 systems would have crashed. Now, make no mistake, 85,000 systems going down is a major incident, but it is highly detectable and, more importantly, recoverable. The rollout would have just paused. Instead, because of that simultaneous rollout rule, a staggering 8.5 million systems crashed. We're looking at a safe project management choice versus the global catastrophe we actually got.
But wait, the nightmare didn't end at 0409 UTC. Point 4 highlights just how complex the recovery was. Most enterprise Windows systems use BitLocker encryption, right? To fix these bricks computers, IT personnel literally needed to manually input a 48-digit key from their Active Directory server. But in a twist of bitter irony, those Active Directory servers were also crashed by the CrowdStrike update. It's like locking your keys inside the safe you're trying to open. This recursive doom loop is exactly why it took Delta Airlines 500,000 person-hours to recover. And point 5 is the ultimate killer here. The governance document for content updates had a blank review date. There was absolutely no mechanism requiring project managers to reassess those deployment rules as the technology evolved.
Section 4. The AI Deployment Parallel.
So let's pivot sharply from 2024 to our reality today in 2026. Because look, this isn't just a cybersecurity story, it is a glaring warning. I want to ask you directly, are your AI agents any safer? Think about it. AI agent updates, model fine-tunes, prompt template changes, these are the 2026 equivalent of CrowdStrike's channel file 291. They aren't traditional code, but they materially alter how your production systems behave. Are you making the exact same project management governance mistakes right now, just in the name of speed?
Well, the data suggests the answer is a resounding yes. According to research from Cinch, a staggering 74% of enterprises that deployed live AI agents ultimately had to roll them back. Let that sink in. This reveals an entire industry acting just like CrowdStrike did, deploying untested, highly complex models to production environments globally without staged rollouts simply because everyone wants to move fast and break things.
And honestly, it gets even more concerning. As this metric from AvePoint's 2026 research highlights, less than 50% of organizations even have full visibility into the AI agents running in their own environments. We are literally in a position where we're deploying updates to systems we don't fully see, we're skipping stage rollouts, and we're relying on monitoring that only catches failures after they've already reached 100% of the target environment. It's a disaster waiting to happen.
Finally, Section 5, the pre-deployment checklist.
We've seen the disaster, so let's transition to the actionable fix. The crucial takeaway here is this simple 3-question project management checklist. Before any update goes live, your team must answer these. Step 1. Name the deployment method. Is it simultaneous or staged? And explicitly document why. Step 2. Define your monitoring baseline. What does working correctly actually look like at 5 minutes, 30 minutes, and 24 hours post-deployment? Step 3. Assign a rollback owner. Who exactly has the authority to pull this update back, and how fast can they execute it? It takes maybe 5 minutes to answer these questions, and it completely eliminates the massive risk of deploying blindly by default. The recovery for CrowdStrike cost $5.4 billion, but this governance fix, it costs absolutely nothing. Nothing except the discipline to ask the right questions before deployment rather than after. So I want to conclude this explainer with a provocative thought. What is your channel file 291, and are you deploying it to 100% of your users right now? I challenge every tech leader and project manager watching this to go interrogate your own deployment pipelines today, before you find out the hard way. Thanks for joining me.